Welcome to this afternoon's live stream. We are going to be working on generating blue noise samples right now. We're going to generate a one-dimensional blue noise sample pattern using probably Michel's candidate method. I'm not really sure yet. We'll try it out though. We'll see what works. I'm going to play some music. Alright, so we finished the blue noise generator this morning. We've got it all ready to release. Now, all I need to do is a blue noise sample generator. And then if we got extra time, I can work on my path tracer. So, to start, I'm going to copy the blue noise generator and delete all these failed attempts, fail folder. But anyways, this is basically going to follow the exact same format with a worker JavaScript file and then the index.html main app. Blue noise sample. Sample list generator. Blue noise sample generator. So that's why we're going to copy it, because they're pretty much exactly the same. I've been switching around some of the options with the stream, so I just need to, yeah, everything's good. Okay. Can maybe make the audio a bit more quiet. Alright, so this is going to be pretty close to the same. I'm wondering, I might not even need a web worker for this. Just looking at it, because I'm wondering what the best way to format it would be. I was just going to do an array of numbers, and then people can format it however they want, because the numbers are really easy to parse. But might want to, at least for GLSO, include vec4 or vec3 encoding. I guess I could always just make a little console thing to do that. Alright, so let's change this around. Blue noise sample generator. Alright, so the settings for this is going to be number of samples, which will default to 100. Hey, Destructor. How are you doing this afternoon? Yeah, you won't need a sigma, don't need density, still need seed though. Yeah, and I'm just going to output them as a double array, so it's easy peasy. And I just need to generate. I'm going to call this count. This up, blue noise sample generator. Gonna need to make this a bit smaller so it matches up. I'm also gonna need to change this part that says it uses void and cluster to whatever algorithm I'm using, but I'm not sure what algorithm I'm gonna use yet, so I'm not gonna set that yet. But I can make this smaller. Maybe it'll be like 180 pixels. Bit less. 150 will be good. Alright, let's look up Michelle's best candidate. Paper. Does this have a link to the original paper? I'm wondering. Paper. Paper. The original paper. Oh. Paper costs money. Well, at least it costs money on this site. Non-uniform sampling images, and this paper non-uniform sampling is extended. Optimality is suggested, and algorithms for approximating optimal sampling are developed. The technique is demonstrated at low sampling densities. So the characteristics of aliasing noise are clearly visible. At super sampling rates, this you should move noise into frequencies above the pass band of the pixel reconstruction filter. Might be on that science paper site. What's a pixel reconstruction filter? May be referred to as decimation, downscaling, or interpolation, accordingly as the sample rate decreases. Okay. Yeah, let me see if I can actually get a link to published in SIGGRAPH. Microsoft Research. No, don't think I'm gonna get this one for free. Alright, guess I'm just linking this. Or I'm gonna save this maybe for later, we'll see. Alright, anyways, I'm gonna delete all this to begin. Because I don't think, delete all of it except for the size part and the seed. because I'm probably not even going to use a web worker. And even if I can just copy this back over. I'm going to rename this. This is something we can post in Discord. What do you mean? That paper. I mean, yeah, you could post in Discord, I guess. It's not a huge deal, though. The method's actually really simple. I'm thinking it won't actually work completely, and I'm actually going to need to add a little plus on disk type thing where it checks if points are too close, but we'll see. I think the issue is that, I don't know, just post it in Discord, it doesn't really matter. Alright, size, seed, that's all. Oh wait, change the path of this, oops. Close without saving. In Discord programming channel. How did you get that? You're at school, so you have you have access. Non-uniform sampling of images is a useful technique in computer graphics because it properly designed pattern of samples can make aliasing take the form of high-frequency random noise. In this paper, the technique of non-uniform sampling is extended from 2 dimensions to include the extra parameter dimensions of distribution ray tracing. Ooh. Which it demonstrated that ray tracing could be used to simulate. Okay, yeah, we know that. Complete block sampling. This goes through everything, doesn't it? It's got the figures sideways. This is an old paper. That's cool though. Thank you for sharing that. I just realized this also needs another option. Dimensions. Dim equals parse int. I think I need to set it to a max of 1. Alright. So I don't know if I want to do this multi-dimensional to start. But to do it for multiple dimensions, I'm going to actually generate the functions with eval, just like how I did with the other version. So you know what, yeah, I'm just going to do that straight away. Generate functions for generating eval. Are you familiar with the Genesis library project? No. Genesis library. A search engine for articles and books on various topics which allows free access to the content that is otherwise payable. That's cool. By Russian scientists, the website became involved in a legal case. Pirate access. LibGen is blocked by a number of ISPs in the United Kingdom. That obviously doesn't work. People can still access it. Alright, so now when I generate, I'll just do eval, generate that, and then I'll run it in a set timeout loop. So it's done. Yeah, you know what? I probably want to do this in a web worker. Whatever. I'll test it here and then move it over to a web worker. No, actually, it's much easier if I just write it for the web worker from the beginning. What do you know about library Genesis? Or Genesis library? I'm actually going to do all the generation here. So I don't need any code up there, I don't think. No, it's a very controversial thing. Oh, huh. Oh no, God forbid people get information, intellectual property. So dangerous. Oh, I shouldn't have removed all that code completely. I'm actually going to copy some of this back. This bottom part right here for starting the web worker and printing the progress. Just message with generation options, dimension. Alright, that's all. I think I will need to add a Poisson disk radius though, just to make it better. We'll see. I'll try it out and I'm gonna add the function for worker update. I can actually copy that from here too, or most of it. And there is another part. I'm actually going to copy this, the part where it outputs the text right here. I guess this raw data text. I should copy this as it goes. First of all, it outputs that message generated in, and then it'll output this text. Alright, so I think what I'm going to do too is I'm going to format it so you can tell where the points are. So if I do total size equals size, or wait, size 2 equals size divided by 2. Or wait, divided by dimensions. And then it's going to output the points together so you can tell which ones are the points by the spaces. Alright, there we go. Man, you know, sometimes, so many times I'm just like, I've forgotten to turn off the camera. Not turn off the camera. I've forgotten to turn it off the camera scene in OBS, so it's just sitting on my stupid face when I'm programming. Now I've got like PTSD where I keep switching back to OBS, going, oh no, did I forget to switch it? Okay, so we have all the stuff set up here. Now we can generate it, size times dimensions. So I don't even need to do size divided by dimensions here, it's just size. Trying to find my post, I found the rough size of it once. Oh, really? I'm guessing it was absolutely huge. Yeah, I want to say it was more than 50 terabytes. Oh my god, I'd be surprised if it was only 50 terabytes. Although I guess most of it is text though, which doesn't take up that much. They have over 50 million books, magazines, comics, scientific articles, etc. That's amazing. Maybe I should look at it more. Although I guess if it's illegal. Apparently learning is illegal. Oh. I am running low on sleep. I really need to catch up on it. Alright, so my idea for generating these points is treating it as a grid. So S size is, or actually first I need to find the square of the size based off the dimensions, which is basically like, for 2D it would be square root. So I think it's math.pow size divided by the number of dimensions, and then subsize is size divided by that size square. So it splits the thing into a grid there. And searches through and finds the point. I actually think I can do this without eval. How long does this have to be? I think it's dimension times maybe dimension? Actually not sure. GP for grid point. GP.fill 0. That at least interests me a lot. It interests me a lot too. Array fill. Defaults to length, okay. Search jittered grid for point farthest away from all other points. Okay, so this part grid position, JP is going to be jittered position. JP equals grid position plus a random jitter based on our RNG function there. We're going to declare RNG right here because it's compiling all this here anyways, so may as well. So I'm actually going to change this to 0.5. Or actually, I'll try making it constant first without any jitter, because I want to test how this actually generates the points. So then it takes that jittered position and it compares it to all the other points. So that's all the points we've already generated here. Alright, so for this, we need to do some sort of something like the void and cluster algorithm still, where it calculates the point farthest away from all the other points. Maybe do min distance. And then we can just do it with squared. This song at the end of... I forgot that they had that. Alright, so the distance is going to be the sum of these points. So dist plus equals difference is the jittered point minus the point of this point, which is output right here. So we need to read that. PI is going to be point index, so points PI plus plus, and then distance plus equals DF times DF, and then MD equals minimum. Alright, that finds the minimum closest distance to a point. I'm going to also actually try doing different equations here. It'll generate different sample patterns, but see what works best. This should probably work okay to begin. And then here, that goes further, finds var min distance, or actually the max distance of that min. And then I think I'm also going to need a buffer to save the position in. Start on SP. So if MD bigger than max distance, SP set jittered position, max distance equals MD. Alright, and now we need to increment this grid position. So you go through the dimensions like this, and you go +1 if GB bigger than equals size square. So you need to do floor. I believe otherwise what'll happen is it won't split the grid properly, I don't think. Mathed around there. So anyways, if that is bigger than equal to size squared, then we increment the next one. If it's smaller than size squared, then we just output it and we break out. Otherwise, we set it back to 0. And then if at the end of this d is bigger than equal to dimensions, then it's finished and we break out of the while loop. If d is bigger than equals dimension, break out of the while loop, and we've got our point. It's at SP. Then we output that to our point. There we go. Let's see if this works. Oh, I changed the URL. That's the wrong page. Alright, count, dimensions 2. Type is not defined. Type. Oh, right here when I'm doing progress. Image ID is not defined. Oh, sweet. So there's our points. And it didn't update any progress. And it also didn't finish either. I need to set this to empty when it's done right here. At least it's generating though. That's cool. Everything is working. I'm just going to increase the size down here a little bit for the text. Alright, there we go, 100 points. Let's test these out. For these. Oh wait, I put a, it's not removing the, there we go. That should fix it. Wasn't removing the comma. So we're just going to loop through and render these points with a distance function. D equals min D, length UV minus back 2, points I plus 1. O equals vec 4, 1 minus distance. I'm sorry, resolution.x. Alright, that's probably too much. Times 10. Oh, I didn't normalize the values. Oh, okay. They're way out of bounds, and they're aligned to the grid. Points. So at the end of this, convert from grid units to normalized 0 to 1. I equals how do I do the conversion? I just divide by size square, right? I think so. Dot length height equals size square. Oh, what did it do there? Was it this that caused that, or? Yeah, it is. What is happening right here? Points I. Float 32 array. Divide equals. Oh, instead of points, this is supposed to be size, first of all. This is weird. It wasn't giving me a out of bounds access error when it should have. Am I looping through I somewhere here? Yes. Wait, no. It's comparing to I. Dimension, seed, no, everything is good. Maybe floor here instead of round. Let me make sure this is actually correct. So 2 dimensions, 0.5, size of 100, the power of 0.5 is 10, which is the square, yeah. Let me try outputting size square. 10. It is 10. So I don't understand how doing points I divided by size square, maybe times 1 divided by size square. I don't understand how that butchers that. Bigger than size, bigger than dimensions. It has to be something just stupid, because for this to just not work after disabling it. I wonder what it is. It's I divided by size square. Minus 1. Float to string. Oh, I have no max decimal places. That could be doing it. Yep, that was doing it. Okay, let's see how this works. It's a completely uniform grid. Okay, so it does kind of work. D minus times I resolution dot y minus 10 point. Alright, so this is displaying the points that we generate. Right now, it's not very good, because if you can see, it's actually displaying these two very close. It should be doing what's called toroidal distance. So we have some stuff to fix up. So that's what we're gonna do. So the first thing I can do is try adding this jitter. And actually, I should set this to negative just in case. Anyways, let's try this. Oh, so that's really interesting. That's actually really good. has some noticeable patterns there. It looks like jittered lines, which is basically what it is. So now what it needs to take into account when doing the distance is wrapping around. So that's done by doing absolute distance, then if absolute distance bigger than size 2, which is the size square times 2, or half of the size square, times 0.5, I don't know why I said 2. You know what, I'm going to try something where I just don't talk and I just program and get this done. So that has some points that are pretty close together right there. I would like to try and do the Poisson disk radius so it stops things from being so close, but it's working pretty well. With the wrapping distance, you can kind of see that stuff avoids each other. Let me just make sure this toroidal distance is correct. I'm going to compare it with the other code here. Toroidal distance bigger than size 2, size minus abs. Yep, okay. So I think besides doing the minimum distance here, I could add the distance around, and it would choose the one that has the least points around it. You know what, I'm going to try increasing this to full random. And you know what? The first point, you know what, before I do that, I'm just going to look at placing the points randomly, or placing the first point randomly. Alright, let's try that. Alright, that's another uniform grid, god damn it. Is it not generating this first point here? I bigger than dimensions. 1 I bigger than size. Points I, oh, this is supposed to be RNG times size squared. Times 0.99. There we go. So now this will still generate the grid of points, but I'm interested to see if it does anything different. Oh, so it jittered those. That was the first point right there, I'm guessing. Alright, so if I do plus RNG, oh, it's generating some points that are outside. So this is actually supposed to be divided by size squared. Oh, that looks pretty dang good. It's just there's some points right here that don't actually look like they have wrapping distance. Like those points would be very close side by side when repeating. Actually, I can render this repeating. Mod times 2 or fract times 2. Awesome, so you can actually see how it tiles now. And if you see, it's not at all equally spaced around the edges here, and that's what the toroidal distance is supposed to do. It's supposed to make the one around the edges here also stay apart. I can actually probably automatically calculate the Poisson radius. Alright, instead of doing this min distance, maybe I should do this. Maybe I should just sum it and the plus equals distance. Let me see how that changes the generation. Otherwise, I do think I'm going to add the Poisson disk generator. Oh god, that's completely messed up. I'm probably just going to do the disk sampling, or not disk sampling, but wait, why are those all so close to the middle? That should be... Did it not generate 100 points there or something, or what? Why are they so bunched together? Alright, yeah, I'm gonna try doing minimum distance. And then what I'm gonna do is I'm gonna calculate a Poisson disk radius. Disk equals, so what will it be? It won't exactly be the size squared. It may actually be a size of 1 or 0.5. We'll try using a constant size actually, because this is normalized to the grid. So what we're going to do is if the max distance is smaller than 1 or some minimum distance, then we're going to try again, because it's not good. We want to find the most far away. So this will make it take longer but have a much higher, much better result, I think. Size 2 is size squared divided by divide by 2. Alright, so if this is going to repeat, it's going to do I minus minus continue, I believe. Maybe this will never complete. Yeah, it freezes. That's what I was worried about. Alright, let's try 0.5. Still freezes. Let me see if this is working correct. Getting an error? No, it's not getting an error. It's just executing over and over again. Max distance smaller than 0.5. Then I minus minus, so it repeats the same one. And then continue. Plus RNG. So it should be trying a different one each time. Alright, I'll try a minimum radius of 0.1. If it doesn't finish here, I don't know what. Smaller than 0? There must be a point where where MD isn't even bigger than max distance, but I don't know. Oh, this is supposed to be 1e8. I completely forgot I added that part. Okay, so let's try with a radius of 1. Alright, that's what I thought. So 1 takes a long ass time to finish. 0.9, I want to find where the limit is. Is it 1 or is it 0.5? I have a feeling it might be 1, but it just might take a really long time. Oh, it might be point... Yeah, it's like 0.7 or something. Oh yeah, that's amazing. So that's exactly the type of sample pattern I'm looking for. If you see, it's basically all evenly spaced while still looking very random. And even at the edges here, there's only like one spot where it has points pushed close together. Let me see, what is it doing there? I feel like this toroidal distance is wrong. Because if it is wrapping the distance, then it shouldn't have these really close together right here. I mean, they're not that close together, but still feel like this can be better. It's looking really good, but yeah, you can especially see here too, they're still right up beside each other at the edges. Let me look up toroidal distance. If you go down, you end up right where you previously considered up. go far enough left, you end up where you previously considered right. How would you calculate the distance between 2 points in the universe like this? Let's imagine a situation. Bigger than 0.5, 1 minus dx. Okay, so I am doing this right. Alright, so if I'm doing it right, then why is it generating the sample points so close together? It must be something wrong with my algorithm. Two dimensions. Let me try letting this sit and generate. I wonder if it'll find a result and actually be correct. No, I don't think it's going to generate a result. How can I make this better? I wonder why it generates these across the edges when it's completely fine elsewhere. I guess it's because it gets to the end and there's not a lot of space. Maybe here I should do the POW dimensions to get the actual distance. I don't know. MD bigger than max distance. SP set jittered position. Max D becomes min distance. And if max D is smaller than 0.6, it ignores. Continues. What is it doing there? Oh, that looks a lot better. It's just got a few points there where it's... So that really makes me think that it's not doing the wrapping distance. Because you can see here these points where it's getting cut off. And it's like right there beside. And like right there, I think there's actually 2 points right side by side. So let me see, what am I doing different here? x bigger than half, 1 minus dx. Minus points pi plus plus. Oh, this is supposed to be size square. I am doing it wrong. Oh, that's perfect. Heck yeah. We got a blue noise sample generator in 3 and 4 and 5 dimensions. Hell yes. Hell yes. And I don't need this POW here because it doesn't matter. Square distance. I just need to convert this to the desired square distance. What we're going to do is 0.8. Six. Okay, maybe 0.5. See how that looks. Basically want something that's fast but still looks good. Oh yeah. That's awesome. Alright, so we got a fast blue noise generator. I gotta fix a bug in it where you can't generate. I never set running to false. Oh, let me just make sure I don't have any sort of bugs in this one either like that. Where do I set running in this? Running equals false right here, okay. False, awesome. So blue noise sample generator is done. I just gotta fix up this stuff. Generate blue noise samples. Download source code. And that's supposed to be source.zip or blue noise samples source.zip. Alright, then we're going to make a minified version of this for putting on the site. So we're going to go to Clojure compiler, go to blue noise samples, and we'll copy this into the min folder. This will be our minified versions. Alright, start with this first. Luckily, I'm not doing any eval code or anything, so this should be super simple. Man, Google Closure Compiler is running pretty slow now. It takes like, even generating a small code file takes a while. Oh, I'm not clearing this at the end. That's something I actually gotta fix that I forgot to fix. Oops. So I need to clear the output divider. Like that. Nice, there we go. Now I need to compile the worker. So this is going to be great for doing quick ray tracers or anything that you actually need efficient samples for, and you have the memory to store an array of samples. Damn, that minified a whole lot. Alright, everything still runs. Hell yeah. Alright, so I'm going to go and publish to my website Marble Race, Blue Noise Generator, Blue Noise Sample Generator. Big updates, big updates. But no, I gotta go. I got family coming over, so I may not get that uploaded, but at least by tonight, I'll have these up on my website. Of course, I'll keep talking about this in Discord. If you want to talk about that, any more of this stuff, I'm always there, talking to the programming section and whatnot. The link to that's down below if anyone wants to watch it. Thanks for anyone who watched today. Hope you guys have a good day. That'll be the end of the stream here. We got some good stuff done. See everyone tomorrow. May actually not be that long a stream tomorrow with my family here, but you never know. See ya.